Simplifying rational expressions. So we have looked at simplifying radicals, and this is similar, and we know how to simplify fractions, and this is similar. So we're going to look at simplifying these things that are like, they just look a lot more complicated. So as a quick reminder, if I have 2 over 4, I can simplify this because both of these have a common factor. Both of them are divisible by 2. So what I am actually doing is I am factoring out a 2 from the 2, and I'm leaving behind a 1, and I'm factoring out a 2 from the 4, and I'm leaving behind a 2. Now I can cancel like terms on the top and the bottom, and I can simplify the fraction 2 over 4 to become 1 over 2. Okay, so we're going to apply that same strategy to this guy. So I'm looking for common factors between the top and the bottom now. Okay, so when we were doing common factors before, we were looking across the row, but now we're going to be looking top and the bottom in this first expression. So I've got negative 35 on the top and 15 on the bottom. I know that both of these are divisible by 5, and so I'm going to factor out a 5. So I'm going to factor out a 5, which would leave me with a negative 7 on the top, and factor out a 5, which will leave me with 3 on the bottom. I'm going to just write out the variables in this case only, just so that we can see exactly how we're going to factor them. So a squared is actually a times a, and b cubed is actually b times b times b. On the bottom I have a, and then I have 5 b's. Okay, so we're not going to write all of this out all of the time, but just for this first example, so that we really understand what exactly we're doing, we're just being really, really thorough. Now we're going to cancel out things that are the same on the top and the bottom, just like we did up here. We canceled out these 2 2's. All right, so I've got a 5 on the top, 5 on the bottom. I have an a on the top and an a on the bottom. I have 3 b's on the top and 3 b's on the bottom. Now I can write my factored expression with what's left over. So on the top, what I have left is negative 7a. On the bottom, what I have left is 3 and 2 b's. And now I'm done. If you can, or when you can, skip this step, you are welcome to go straight from here to there. Okay, number 2. So this one doesn't appear obvious. I've got a bunch of these. These terms are not combined. They are part of a whole term. So I'm not going to be able to do the same strategy. So the first thing I'm going to look for is just common factors or other factoring techniques. So on the top here, I've got a common factor. I can common factor out this 4. Common factor out the 4 is going to leave me with x plus 2. On the bottom, I have a trinomial. And I can factor a trinomial by finding 2 numbers that multiply to 6 and combine to 5. So as a reminder, I'm looking for 2 factors of 6. Now I know they're both going to be, I'm going to put my x's in here and my signs. They are going to have the same sign because 6 is a positive, and they're going to have a plus sign because the center term, the b term, is positive as well. So I know 6, and I'm looking for 2 factors, both being positive, that combine to 5. And hopefully 2 and 3 kind of came to mind there. 2 and 3. Well, now all of a sudden, now that I've factored this by common factoring the top and doing a simple trinomial on the bottom, now I see I actually have common factors. I have this x plus 2 as a common factor, so I can get rid of that on the top and get rid of that on the bottom. In the end, I'm just going to be left with 4 over x plus 3. Let's try another one. Negative 6a plus 2a squared. On the top, so I'm going to start again with my factoring thinking process. I'm looking for common factors first. So I've got a common factor of 2a on the top. That's going to leave me with negative 3 plus a in the bracket. And on the bottom, I have a common factor of 4. That's going to leave me with a minus 3 on the bottom. Okay, and just as a reminder, negative 3 plus a is the same thing as plus a subtract 3. So these are common factors. And actually, I also have another common factor now. I didn't notice this initially. Now I've also got this 2 that can be common factored with that 4. So in the end, this is going to just reduce down to a over 2. All right. Up next, I've got a trinomial on the top. And I've got an x squared term, a subtract term, and a perfect square on the bottom. So I've got a difference of squares on the bottom. So let's do the top first. I've got a trinomial. I don't have any common factors, so I'm looking for two numbers that multiply to negative 12 and combine to negative 4. If this is slow, if this is hard for you, it's a good time to pause and think of those factors yourself. I'm getting to negative 12. I know I'm going to have 1 plus and 1 minus. I'm going to have a negative 6 and a positive 2. On the bottom, I have a difference of squares. So when I do that, I'm looking for two numbers that multiply to negative 36 and combine to 0 because I have no b term. I have 1 plus and 1 minus, and I've got a 6 and a 6. I've got the common factor of x minus 6. And so my final answer is x plus 2 over x plus 6. Okay, so I can't do anything more. These are part of the term, so you cannot common factor anything else here. Okay, so this is in brackets still. You can't common factor these x's or these 2's. This is done. Okay. All right, moving on. 4x squared plus 4x minus 15. So now I've got a difficult trinomial up here. I don't have any common factors. So I'm going to maybe give myself a little cheat. And I'm just going to wait on this one, and I'm going to common factor this bottom one out first. Okay, so I know that in the bottom one, I'm going to have a common factor of 3. And after I common factor out the 3 on the bottom, I'm left with 2x minus 3. So if I'm really thinking that I can reduce this expression, then I'm thinking that I'm going to either have a 3 on the top or this 2x minus 3 factor on the top. And because I know I'm setting up for trinomial factorization, I probably am going to have this as my common factor on top. So I'm just gonna put it in here just to see how it goes. Okay, remember we're trying things out when we're doing factoring hard trinomials. We can certainly go 4 times 15 and then find two sets of factors that combine to 60 give you 60 and combine to positive 4, or we can just kind of give ourselves a clue by looking at what is on the bottom. Okay. If my first term is already 2x and I need it to be 4x squared, that means the first term of the second bracket must also be 2x, so that when I FOIL these, I have 2x times 2x to give me 4x squared. If the second term is already subtract 3, then in order to get to 5, I must have a plus 5. So because I just kind of guessed this based on how the bottom factored, I want to double check and make sure all of my terms are correct. So f, first times first, 2x times 2x, 4x squared. O, 2x times plus 5, that's 10. I, negative 3 times 2x, that is negative 6. 10 minus 6 is 4. Negative 3 plus or times by 5 is negative 15. So this is factored. And I was right, my guess was right, was that these guys would be able to be reduced. So now I can just write my final answer, 2x plus 5 over 3. Okay, last one. X minus 7, there is nothing in common. It is not a trinomial. There's not even a squared term, so that's already factored. So I'm just going to write that again. 14 minus 2x, well, that has a common factor of 2. I'm going to put a 2 out here. 14 divided by 2 is 7. Negative 2 divided by 2 is negative 1. X. Okay. Now, this looks like maybe it's done, but if you notice, it's actually kind of similar. What I have up here is just the opposite. I have a plus x minus 7, and then a plus 7 minus x. So I'm going to actually factor out a negative 1 here. So I'm going to factor a negative 1 from the bottom. This way I'm going to change the signs. Okay, so I'm going to keep this on the top, same as it was. I still have my 2. I'm going to factor out a negative 1. And now 7 divided by negative 1 is going to give me a negative 7. And negative 1 divided by negative 1 is going to give me positive 1. I'm just going to get rid of that 1 and leave an x. Now, these two are the same. Positive x minus 7 is the same as negative 7 positive x. So now these two cancel out. Well, I can't be left with nothing on the top. So I've really factored out a 1 from this expression. So in the end, I'm going to be left with 1 over negative 2. All right. Homework pages, page 99, 3, 5, 7, 9, 12, and 13. Sorry guys, there were a few more rules that we should have talked about really quickly. Okay, so you can only cancel terms if that whole term can be canceled from the top or the bottom. So like in this case, if we have x plus 2 times 3 over x plus 2, this whole term, x plus 2, can be canceled because they're the same on the top and the bottom. But if we have like x plus 2 over x plus 3, you cannot cancel, can't cancel part of a term. Okay, you cannot cancel out these x's and just be left with 2/3. Okay, this is part of a term. For these, for the steps, the first thing that you're going to want to look for is a common factor. If you have a common factor, that's easiest. After that, you're going to look for, maybe you can factor using trinomial factorization or find a difference of squares. If nothing's kind of coming up, you might want to factor out a negative 1, just flip those signs around. And then number 4, which we should have probably done when we went through all of these, is state any restrictions. You're going to have restrictions anytime you have a variable on the bottom. So looking back through, we'll take a quick look here. No variable on the bottom, no variable on the bottom. Oh, variable on the bottom, x cannot equal negative 6. Variable on the bottom, that's a squared term, so no restrictions exist. Variable on the bottom, x cannot equal negative 3.